This is Physics 2211, Lab 2, Motion of a Fallen Object by me, Eric Brown. Table of Contents. First, I'll be discussing the introduction, the experimental data, the computational data, the results and analysis, the discussion, and finally, the conclusion. Introduction. Purpose. Compare the position versus time graphs of the experimental, computational without drag, and computational with drag freefall motion to further understand the principles of motion. Results. As you can see in this graph, you can see the three different experiments. Models and fundamental principles. Newton's second law, the force on an object equals its acceleration times its mass, or F net equals ma. Velocity update formula. The final velocity equals the initial velocity plus F net over m times the change in time. Position update formula. The final position equals the initial position plus the average velocity times the change in time. Force of gravity. Force of gravity equals mg times the negative of the unit vector j. Force of drag. Force of drag equals b times the magnitude of v squared times the unit vector j. And if there is no drag, F net just equals F gravity. Experiment video and tracker. Initial conditions. There are 0.033 seconds between each tracking point. I dropped the paper ball at shoulder level. I started with zero velocity. I created a Y position versus time graph. The system was the paper ball. The surroundings are the earth from gravity and air from drag. And as you can see to the right for the experiment, I dropped the paper ball, analyzed it using the tracking app, then plotted the points to the right in the data table. Computational model with no drag. Assumptions. Gravity is the only force acting on the system, and it started at zero velocity in position 0, 1.683, 0. Here is the code for the initial conditions, where b equals 0, and here's the code for the forces, velocity, and position formulas, where for the force of gravity, it equals the mass times negative g times j hat, and the net force only equals the force of gravity. Computational model with drag. Assumptions. Gravity and drag act on the system, and it started at velocity 0, position 0, 1.683, 0. The code for the initial conditions are very similar, but b is now equal to 0.3 instead of 0. And then the code for the forces, velocity, and position formulas, you can see we had to calculate the ball speed for the force of drag, and F net now equals the force of gravity plus the force of drag. Analysis of results. For the first half of the curve, there is very little variance for the three lines. For the second half of the curve, the experiment and gravity plus drag model have little variance, while there's lots of variance with the gravity-only model. You can also see when looking at the velocity versus time graphs of the no drag and drag, the no drag has a linear negative line, while the one with drag starts to curve and level off at the end. And as you can see with the paper ball and the two arrows, that would be the free body diagram of the paper ball, the system. Discussion. What does it mean? The chart without drag is linear and downward, so the downward velocity is increasing at a linear rate. While the chart with drag is inverse, so as time goes on, the rate at which the velocity downward increases decreases. So the chart with drag predicts the terminal velocity because it starts to level off. And at terminal velocity, the velocity would remain constant, so the acceleration is 0, and F net would also equal 0. What if? The terminal velocity stays the same because, as you can see in both charts, they both level off at about negative 5.75 meters per second, with the graph to the left starting at 0, 0, 0 meters per second, and the graph on the right starting at 0, negative 5, 0 meters per second. Conclusion. Experimental errors might have been the paper ball I dropped was not perfectly made so that the drag was constant, which leads to some errors. Another error is the tracker app was not able to perfectly track the center of the paper ball every single moment, so the data provided by the tracker app may not be 100% accurate. Then the differences and similarities of the models are the experimental and the computational with drag are very similar because they have very similar forces acting on the system, while the computational without drag is different and hits the ground sooner because it has a greater acceleration and downward velocity because the only force is gravity acting downwards and it has no drag acting upwards. The end. Thank you for watching.